Okay, my friends, this is going to be a lot of fun today. All right, this is Don Lincoln. He's from Fermilab, and I go back a little ways with Don. We've gone back and forth about my theories and his theories, and I support his theories about the actual particles. There's a point particle and a fixed particle. We've shown them, and I'm trying to engage with Don, and he's, we sort of chide each other a little bit, but, that's just the way physics works. Because I have a different interpretation than him, so we sort of needle each other a little bit, and that's what I'm going to do today. All right, Don, get ready, buddy. All right, I'm going to show you a video Don just put up. I put this one up saying space is a quantum foam, and just as I said, exactly like Fermilab says, these particles exist. Well, the next day Don put up this video. It's kind of funny. All right, again, this is in good spirit. This isn't meant to be nasty. I think Don's coming around. So here's what he has to say. I believe he's addressing my video. Here goes.
Many of you who watch this channel actually know quite a bit about physics, which makes sense, of course, because, well, you're smart and that whole physics is everything thing. And you ask questions about things that don't make sense to you. A super common question is, how can a photon, which has no mass, have momentum?
All right, there's the key. I said that they do have mass, and they do have momentum, and they do have energy. And if they had no mass, there would be nothing there. There's nothing that is something that has no mass. So he's going to listen to what he says.
That's a good question with a lot of complexity in the answer, so let's dive into it.
All right, now I want to tell you something. It really gets silly, because here's what he has to say. He says the equation for momentum, he's got to build up the equation so you can understand. Listen to this.
Equation says that momentum, which is written as p, is equal to an object's mass, written as m, times its velocity, which is written as v.
Now listen.
P equals mv. That's the equation. And you immediately see the problem. Well, a photon of light travels...
You immediately see the problem. Come on, Don, let's get real, my friend. When you see what goes through here, and you're going to have to watch this on your own because it was a snooze fest, I'm telling you. Listen to this.
This Ke equals 1/2 times the mass m times the velocity v squared. So we say that Ke equals 1/2 mv squared. You probably remember all that.
Oh, of
now
course.
Let me show you how kinetic energy and momentum are related. Let's start with the momentum equation, P equals mv. Now square both sides. You get P squared equals m squared v squared. So far so good, right? Now divide both sides by m. On the right hand side, the bottom m cancels one of the top m's, and you get P squared divided by m equals mv squared, which should remind you of something, specifically the kinetic energy equation.
Oh, obviously. This goes on and on and on. I mean, look. He goes into this one here, and then finally ends up with classical physics. Now, let's let him just finish up what he has to say, because he's going to get into Newton and all that business. All right, here he goes. Kinetic energy is related to momentum. Absolutely.
Related. We have an equation with energy on one side and momentum on the other. And this kind of means that anything with kinetic energy must also have momentum.
It also must have mass, Don. If there's kinetic energy there, what is moving? If there's nothing there, there's nothing there.
Of course, we still have that m kicking around, which is 0 for photons, so I haven't really answered the question.
Well, you're not kidding.
I didn't intend to at this point. I just wanted to show you that kinetic energy and momentum are related, even classically.
This is, I got to be honest, Don. You're talking circles, my friend. I love you, but you're talking circles.
Okay, now to get into something you might not have known. Let's move into this new material.
All right, this is the new material. This is the new material that I have brought to the table. Here we go.
And I want to tell you something, and that is that these equations aren't completely true.
This is how you wiggle through these kind of things. This is kind of funny.
That's right. You've been lied to. Wake up, sheeple. The man is lying to you. Man, I have always wanted to say that in the video. Why should others have all the fun?
Yeah, it is a lot of fun, Don.
Of course, like a lot of times when people toss around the word sheeple, what I just said was a little misleading, and the real story is a bit complicated. The real truth is that those equations are special cases that only work for objects with mass that is moving at slow speeds. And of course, I should be upfront that when I say the man is someone like me. So I guess you have to decide whether to believe me or not. But you should, because, you know, I know stuff. And it's way cool.
I bought a car from a guy who sold used cars. And I said, why should I trust you? And he says, well, everybody trusts me. I said, well, why? He says, well, I never lie and I'm always right. And he says, plus I have the 30-30 guarantee. I said, ooh, that sounds good. What does that mean? He says, 30 days or 30 seconds, whatever comes first. The car didn't run all that well. Okay, this is going to be a good time. This is Fermilab. This is Don, and he's saying that this is the fixed particle, and this is the point particle that can and might not have any mass whatsoever. This one has a hell of a lot of mass, I can guarantee you that. And together they make photons. So photons do have mass. They are not massless. So momentum is just a factor of, it's just a piece of matter going forward, that's all. It's not nothing. There is no nothing, there's nothing, there's something. If nothing's nothing, it's nothing. If something's something, it's something, Don. Let's get real, my friend. Okay, I said to Don, I said, I agree with you. These are the particles that we have seen. I think he was upset because we saw them. They have never seen them, they just predicted them. But here's Don's statement on this. It says, in summary, extended particles, which are the big black ones, have a fixed size. 100% agreed on. Although they may have a fuzzy edge, which is that little red edge. I'll show you these again in a second. Point-like particles are the mathematical abstractions which have zero size. Now, how is that possible? But even zero-sized particles have an extended field due to the effect of the field surrounding them. Well, there is no them. That's Don Lincoln. Now, he also talks about the quantum foam, which is exactly what I say. Space is filled with these particles. He agrees. He says it's a writhing. He says it's not nada. There's nothing out there. No, that's wrong. That's not what happens. There is nothing out there. There is something out there, and that something is in the quantum scale, which is light particles. Space is writhing, frantic, ever-changing foam. Absolutely agreed, Don. The quantum foam is real. The microcosm is in continual motion. There's just everything out there is continually going on. Again, Don Lincoln. I agree, Don. 100% agree, my friend. So, why are we in disagreement? All right, so once again, just remember, this is the fixed particle Don talks about with the fuzzy haze around it. It's that one right there. It's the black particle. And I believe it's dark matter. They don't change. They stay the same size, the same one this is over here, exactly the same. Now, this is coming through the air this way. All right, you see the glowy little particles there? I don't know if you can see them or not there. But they are, what this one does is concusses, because it's the leading tip. And then it glows up like that, which is exactly what Don says. I have no dispute with him, except this is a photon, and it absolutely has mass. And it absolutely, I can't imagine somebody saying there's no mass. There's nothing there. Obviously there's something there. Obviously it hits solar panels and makes conduction. These are the kind of things that I need to discuss with Don, and he's sort of doesn't want to get too involved in the discussion. He wants to make a little fun of me, but I'm going to show you what he did today. It's kind of cute. I mean, well, this was yesterday, a day after my video. And I've gone through this with Don for quite some time now. You know, we went back and forth, and finally we just broke it off because it was leading nowhere. And, you know, I was starting to get frustrated and being a tad nasty. You know, it grows on you after a while. So I'm really happy to see that Don is giving in. Thanks, Don. Now, once again, I'm just teasing. He needs to look at my work, because I've shown you the particle exists. The particle is a particle. It obviously has some kind of mass. You can do all kinds of things with light. Hit solar panels. There's conduction. You can drive these little Crookes radiometers with a light. You know, and actually that's reversed light. That's absorbed light and then spitting light back out, believe it or not. It's the black panel that absorbs it and then spits it back out that drives the black panel. So it's absorbing mass. And this I'm absolutely certain of. There is no question whatsoever. And I even worked with weights and measures, and the weights, when they have to weigh the test weights, they have to do it in ambient temperature. They can't have a difference in temperature. The particles that are in there are literally light particles. They're atomic vapor. And they have a weight, and they flow out into the ambient temperature. And when they put them in the weights and measures, I talked to the guy. I said, well, why can't you weigh them when they're cold? He says, I can't weigh them when they're cold because they don't weigh right. I said, why? And this goes back, 40, 50 years ago. And he said, nobody knows why, but they don't weigh right. He says, we think it's got something to do with the movement of the air inside because the fall, you ever open a refrigerator door, freezer door, you can see the vapor fall out sometimes. Well, he says, yeah, we don't really know. Well, I just blew it off, and because I delivered these weights to be tested, and they were cold. And I said, can you just test them? I don't want to have to come back. He said, no, you got to leave them overnight. They have to come to ambient temperature. And I said, you got to be kidding me. And now I see why. Everything falls into place sooner or later, Don, if you pay attention, my friend. By the way, Don's got a lot of doodles there. Well, I went through all those doodles. I drew them 50 years ago. They never write down, and they're still not right now. However, this is right about resonance, frequency, shaking, vibration, atomic bonds, different types of overlaps, dipole moments, hybrid molecules, and now we get into magnetic properties. Two types, dipole to dipole interaction. Case closed. There is no big solid core. And this, Rutherford's atom was wrong. Bohr's postulate's totally wrong. Transfer of energy is from light to atomic vapor. Everything here is made out of the same particles that makes up light. It is atomic vapor, and everything is atoms, which is made of that atomic vapor. And believe me, I did it all. I'm just going to scan through this very quickly so that you can see what I did do. I went into chemistry, thermochemistry. I went into, all of the light and lasers, and here's chemistry. All the different principles and everything was based on. You have to understand the principles behind everything, and Don doesn't seem to understand that. You have to get to a point where thermochemistry. And I did all the tests. Here's all my light energy stuff about photons, packets of particles, packets called photons. They're particle nature. This was all. This is not something I just did in 15 minutes. I'm still doing it today. And I had to get out of this because nobody would listen to me. Nobody talked to me. And that's the problem. So that's why sometimes I get a little combative. But I don't mean to. I like to be friendly and have a nice time. And I think that Don and I can get along well. I'm hoping for that. All right, I tell you what. Let's just let Don continue on from here and see what he has to say about how we can get momentum without having anything causing momentum.
Now comes the next surprise, and that surprise involves Einstein. Of course, Einstein was all about moving at super fast speeds near the speed of light.
All right, let's just talk about that for 1 second. I'm going to kick in every here and there as we go through this because I haven't even watched it yet, to be honest with you. I wanted to present this as I watch it. So here we go. Well, Einstein is all about the speed of light. Now he's talking about things moving at super fast speeds near the speed of light. Well, how do you get to the speed of light is the speed of light. So how do you know what I mean? They know it can slow down. We have showed it accelerate. And we showed the particles that Don has been looking for. Okay, really quickly, I've shown this hundreds of times. Light from a red laser with a completely black background. We're picking up particles in the air that are concussing with this wave of magnetism, forcing them to display some form of energetic reaction. That is the tip of the laser, and everything that's in front of it has to get out of the way. They glow a little bit. That's just the nature of the particles of of these electrons. The white part glows. There's also black parts attached all over the place, because these are the particles that are in the air, and they are the particles of light. Here they are right there. You see them? A black and a white, a black and a white. These are photons. You see it? And this one has the leading edge down, this one has the leading edge up. They would call that up and down spin. This is that particle wave, which was here, going nice and slow. It looks to me like it's accelerating. I don't care if it is or not, it doesn't matter, because at here, we can see the particle making its way out of the wave and accelerating, concussing right here, and dividing, creating sterile muons, which is what Don Lincoln's looking for, and electron showers, and then combining back here. This is fission. When they separate, it's fission. The black and white were together. I showed you those particles right there. At this point, they break apart, and the white leaves the black, and the white turns into a shower, and the black stays the black muon. These are the Higgs fields. As they come out, as this spray comes out, and it reconcusses with reality. I mean, because at this point it's just, I don't know what it is. All it is that white particle into a spray form. So I don't know, there might be, they can get bigger and smaller. We know this. This is what they call a point particle. Don calls it the point particle. He's right, it can get big and get small. And I could show you that elegantly. And I will right this minute. All right, this is what that point particle is, right there. That's the point particle, the red one. It's the glowy one. That's the fixed particle with the little field around it. You know, exactly identical to what Don Lincoln says. I agree. However, there is mass here. Of that, there is no question whatsoever. And I want to see what his conclusion is, because there's no question that's got mass. And by the way, that is precisely what Don is looking for, is these muons. You see this? Muon neutrino stays the black ball, it stays a muon. There it is right there, the black ball, never changes size. And that's the fixed particle. We made a Venturi just small enough that we wouldn't let it get through. That's all, simple as that. And we're letting the white come through, and when it does, it forces itself into each other's fields, and then they concuss and explode away from each other. And then they reattach back to the muons once you get out into back to reality, which is only just a bazillionth of an inch away from the Venturi. This is very, very expanded. So this is what Don's looking for, is the muon and the electron shower. Now I think he's a little upset that we found him and we didn't spend quite as much money as they did. And you know, that's all I can say. Okay, so now we know that Don is basing his assumptions on the particle that I showed you has no mass, which is wrong. Einstein based all his assumptions on light has one constant speed, and all the rest of the stuff he said was wrong. So Hubble's got to be wrong, Bohr's wrong. Virtually everybody was wrong that based their model around a big solid core positive nucleus. It doesn't work. And that's why when they smash apart the nucleuses, like Don does, he sees these particles, they just don't know where they came from, because they're just dealing with a bunch of debris. We're dealing with light, and we can see the actual particles. So, one more time, I applaud Don Lincoln. All right? I do not disparage him whatsoever. I applaud him for his stance on standing up and saying, here's what things are. But then you have to engage and say, okay, well, Roger said this, I said this, boom, boom. Now, he's kind of laughed at me. He came out one day acting like a silly robot, a drunken robot, and saying, oh, there's a silly, stupid guy on the internet saying he can, you know, accelerate light. And that was a couple days after I sort of went sort of a little bit after him, saying, I can accelerate light. You guys can't do it. I could do it. I was kind of, you know, sort of being the way I am. You know, I found I had to be a little harsh to get any reaction. Well, he did react, and then we went back and forth quite a bit, and then we sort of parted ways, because he just, and he's never mentioned my name, and then he comes out today saying, oh, I always want to go against the man, and he's the man. He knows that I'm going against him. You don't see everybody out there screaming about Don Lincoln. I've been doing that because he's the guy that's running our energy department. We'll look at this stuff. So I sort of figured I had to be a little on that side. So Don, I don't mean any nastiness, my friend. I just want you to take a look at it. And I'm going to keep doing this until somebody does take a look at it. And the longer you go, the less favorable you'll look, buddy. So take a look. I'm always willing to speak. As I told you, we can have any kind of conversation you'd like. So let's see what you have to say about the nature of the particle in physics, and Roger will respond. Okay, so here goes. We're talking about Einstein. Let's move back a little bit so we don't miss what Don has to say here. Well, actually, let's go back to where he claims he is the man.
A lot of times when people toss around the word sheeple, what I just said was a little misleading, and the real story is a bit complicated. The real truth is that those equations are special cases that only work for objects with mass that is moving at slow speeds. And of course, I should be upfront that when I say the man is someone like me, so I guess you have to decide whether to believe me or not. But you should, because, I know stuff. And it's way cool.
Way cool.
Now comes the next surprise, and that surprise involves Einstein. Of course, Einstein was all about moving at super fast speeds near the speed of light, so you know that he's going to pop up in any discussion involving photons and momentum. And when you think about Einstein, you almost always think about his famous equation, E equals mc squared. And guess what? That equation's wrong too. Come on, sheeple, wake up! How long are you going to stay fooled?
I've been talking about that forever too. It's ridiculous. Well, anyway, let's let Don go. The speed of light is not constant, first of all. Mass is not just how much something weighs. Mass is a compilation of the weight of the particle and how hard it impacts, and what the value of the thing it impacts, how gushy it is. If it hits a pillow, there's not a whole lot of energy. If it hits something hard, there's a lot of energy. As simple as that.
Okay, I promise. That's the last rant. But the rant has a super tiny kernel of truth. E equals mc squared is also an approximate equation, and one that only works for objects with mass that are stationary. It's not a general equation, and it doesn't work for massless objects, nor objects that are moving.
Or anytime on a full moon.
In fact, I made a whole video just digging into the limitations of this equation.
Well, you're not
the link
kidding.
is down there in the description. Watch it later if you're interested. So now we're ready to get to the truth. I put the three equations I've mentioned so far here. E equals mc squared, P equals mv, and Ke equals p squared divided by 2m. And all of these equations are just fine and correct, but they are all equations that only describe objects with mass that move slowly. Those equations fail in other situations.
I don't know what to say, but I won't say anything at the moment.
It turns out that there is a more general equation that works for all situations, and it looks kind of like Einstein's famous equation. This equation is energy squared equals the momentum times the speed of light squared, plus the mass of the object times the speed of light squared, all squared.
Don, that's a very square way of looking at things. This is what everything consists of. Electrons. You call them muons and electron neutrinos. I call that an electron. I call that dark matter. I call that gravity. I call that heat and energy. And just exactly what you said. The fixed particle never changes. The point particle gets big and small. I've shown it quite well. Together, two of these together, electrons, which would burn into you if they attacked you, they would turn into heat, and if there was enough of them coming at one time, they would burn you as electric heat, like static and lightning and so forth. Photons will bounce from you, creating light. And depending upon the impact value, we get the different lights, different colored lights and so forth. Now, protons are made up not of one big chunk like that you can smash and breaks into bits. It's made of 1,839 of these particles in a ball. And the dark matter can go towards the center, and it's encrusted with white matter around it because they want to get away from each other. This is the new model, and that's the whole model right there. The electrons still have a weight, which is 0.0005854, I think, something like that, atomic mass units. It's very, very tiny, because 1,839 of them have to be added together to make one proton. And as far as I could determine, I think Don's right, that the muon has virtually all the weight, the fixed particle, and the electron neutrino has almost no impact value. This is an impactor like crazy. That just pushes things like crazy. This one here just burns. And we see that on an atomic bomb blast, because the first thing to hit is the white particles. They're on the outside. And in very, very, very slow motion, you can see they just burn the house. And then the next thing comes is the black ones behind it, pow, and the house goes flying. And then everything comes back, because the black particles that were in the central core that exploded are still in, there's quite a bit of them in a mass there. So everything wants to come back to that, because they want to be attached together. That's the nature of the gravity of that dark particle. And it's exactly identical to what you see in atomic bomb blasts. So all of these equations are just wonderful if you want to make something up that only works on the full moon if there's no wolves howling.
E squared equals PC squared plus MC squared, all squared.
Obviously.
Now this equation works for everything. Massive objects, massless objects, things moving near the speed of light, things moving at the speed of light, and things that are stationary. And we can look at the special cases. For instance, let's see how...
Don, all these are numbers and little signs and squiggly little this and that. Well, I'm going to let you talk because I shouldn't interrupt you. I'm sorry, my friend. But he's saying these work for everything. Well, I don't see anything working here at all. I showed the pictures of what actually happens rather than little doodads and, you know, and I've done all the doodads and the little doodles that Don's done. So, you know, I'm not saying against those things because I don't understand them. I'm saying against those things because I fully understand them.
It works in the special case of a photon. Since the photon has zero mass, this second term on the right-hand side goes to zero.
Completely wrong, first of all. So let's see what he continues on this completely wrong path.
And we have that energy equals momentum times the speed of light. So here we see that energy and momentum are equal, except for a constant. And if an object isn't moving, then its momentum is zero, which means that P is zero, which gets you back to Einstein's equation, E equals mc squared. So I guess the first lesson is that when you learn an equation, it's super important to understand if it's a special case or not, and if it's a special case, when it applies and when it doesn't.
All right, there is no special cases. There is no special cases. This is the case. It's a new model. The Bohr model, this has never worked. Never worked. All right, so Don, let's continue on. I'm sorry to interrupt you, my friend, but I will when you're making mistakes, which will be pretty much all the time here.
The bottom line is that the familiar equation, P equals mv, just doesn't apply for massless photons, and the question of photon momentum, well, completely sensible, arises from using the equation in the...
Whoa. These are the statements he makes, completely sensible. Where did that come from? Let's listen to this.
Your equation, P equals mv, just doesn't apply for massless photons.
Obviously.
And the question of photon momentum, well, completely sensible.
Completely sensible. Photon momentum is completely sensible if there's something there. But if there's nothing there, there's nothing there. And it makes no sense whatsoever.
Arises from using the equation in a situation where it was never intended to be. I could spend a long time showing you how you can manipulate this general equation that equates energy, momentum, and mass.
This is just insanity. Believe me, I've gone through all of this. I fought the law, and the law won. But if you look at this stuff, this is saying that I think it's in the Bible or somewhere that says these teachers will come up with tales they concocted tales to deceive you, which this is it right here. This is not reality. I mean, come on now. Who's going to look at that and say, oh yeah, we understand. No, come on. I'm showing what happens in reality. You can make up, I've done all this stuff. I understand sodium chloride and carbon dioxide and oxygen and hydrogen and water and aluminum silicates and all that stuff. It's just a way of impressing somebody to say, after you've seen, just like Don Lincoln said, well, I know stuff, so you got to believe me. Well, this stuff you know, it means nothing. It's absolutely nothing at all. So I'm going to give it to the man. Here we go.
But I will leave that you to play around with if you want. And I put a link in the description to a couple of websites that do a lot of the heavy lifting for you. By the way, let me canalize you a bit. That 1/2 mv squared thing is itself only an approximation for kinetic energy that works only at very low velocities.
Boy, that's a tantalizer, Don.
There are more precise approximations. There are endless levels of complexity.
Boy, you're not.
So that's the equation-y way thinking about this. The equations very clearly show that energy and momentum are related, and that an object that has energy also has momentum, even if it has no mass.
No, insanity. No mass means there's nothing there. There's nothing there. How could it have energy if there's no mass?
But maybe you're looking for something deeper, something more intuitive. You think that perhaps mass is somehow special. Well, let me disappoint you there, too. To first approximation, modern physics has proven that mass is an illusion. There is no mass. Now,
Modern physics has proven. Come on, Don. How does it prove it? Let's see how it proves. Now, I made an entire video on this topic and put a link in the description for you so I can show you a bunch of more nonsense.
made an entire video on this topic, and I put a link in the description for you to watch. It's one of my favorite videos and definitely one of the most mind-blowing. But let me just sketch it out here for you. Just expect that everything you think that you know about mass is about to be upended, and watch the video to get the whole story. You are made of mass, which is true of anything that is made of atoms. The mass of objects made of atoms is found in the atoms' protons and neutrons. The electrons pretty much don't matter.
Oh, Don. Oh, my friend. Everything's made of electrons, but they're dipoles. They're dipoles. He's saying there's this some gigantic positive center, and these little electrons are all floating around, and they have no mass. Oh, my goodness.
But protons and neutrons are made of smaller objects, which have very little mass, nearly none. So
Yeah, they're
where
called
does the
electrons.
mass of protons and neutrons come from? Those objects are orbiting around each other at crazy fast speeds. You can think of protons and neutrons as tiny subatomic tornadoes, vortices of motion and energy. And that's all they are. If you look at them, there is nearly no mass in the way that we intuitively think about mass. Mass is just energy. So assuming that...
That's just wrong, Don. Absolutely incorrect, my friend. Everything there is an atomic vapor. And when it's added together at certain resonance frequencies, and I honestly cannot say exactly why these resonance frequencies build and make these molecules. They say, oh, they were all made at the Big Bang. I don't agree with that whatsoever. I believe they are constructed within bodies by bacteria to create the vitamins and minerals and all of the building blocks for your body. Bacteria do that. They're absolutely unbelievable chemical factories. Bacteria create enzymes and catalysts that do unbelievable amounts of chemistry instantly. That's what bacteria does, and that's what saves you, and it protects you, and they live in your membranes in your body. And I believe that's why your body gets all of its nutrition that it needs if the bacteria is good in your body, because it can break down the molecules and reconstruct them into new molecules, sulfur and zinc and everything else. So you didn't need a whole bar of zinc to get the zinc. It's in all kinds of different foods and so forth, yes. But you need bacteria to break that stuff down into the molecular range where your body can use it. Otherwise, you can't use it. You can't eat a bar of zinc and it goes right into you. Now, okay, here we go. So, everything he said so far has been wrong. That's my interpretation.
That you're willing to accept that, and you really should watch that video because it shows this idea in far more detail. Then moving mass is just moving energy. And of course, a photon is moving energy. So when you get right down to it, a moving photon or a moving proton are not so different. Both are nothing more than moving energy. So if a moving proton has momentum, so does a moving photon. And that's really all there is to it. On the other hand, I predict that this whole topic has made you think very differently about mass and energy and how they really aren't all that different. The more you learn about the subatomic world, the more you learn that it's some crazy stuff down there.
Oh, Don. All right, I just want to point out that I've been really hot on the trail here. 9 days ago, I did light speed shown to accelerate even in the air, which I think I showed that pretty well. Good. I'm talking about the pole shift is due to the particles that are in space, the quantum foam. I'm talking about space is filled with particles. Let's look into this, please, Fermilab. Energy independence. We can get this in 30 days using the particles I'm talking about that we just saw accelerating. We saw fission and we saw fusion. If that's correct, we should be able to get free energy. And all of these particles, these bits exist already. I'm showing them. I'm showing that division right there. I'm showing fission and fusion. Is it possible? All right, I'm going with absolute zero. Why is that? Absolute zero means there's absolute zero electrons left in the particles. Space quantum foam, just like Fermilab says. I'm trying to get Dr. Michio Kaku to respond. I understand all this stuff extremely well. Better than any of the people that we have in charge right now. So I would like to be involved. And either we can just sit around and hope for the best, or we can look at some things that mean. Even they changed the periodic chart. They've changed the periodic chart because the nuclear core is shown to be wrong. They actually could see that the nuclear core is wrong, and they had to change the periodic chart. That just happened 4 days ago. Big press release about it.
Google
Let me see, hold on. I think here it is right here. March 29th, 2022. Press release, visualizing the invisible, a new model to aid interpretation of atomic resolution molecular images. Listen to what I had to say here in this video, and this goes back a week or so. And it's time to give up on the Bohr model, not necessarily give up on it, but at least examine what I'm showing. Okay, my friends, press release today, just dated today, March 29, 2022, and they realize now that the atomic model is not correct and they cannot fit it because they have come up with new photographic techniques to actually view the particles, and they don't work. So it says it's finally all right, there's no reason to go through this whole thing, but they did. They realized it doesn't, the nuclear core is not anything like they thought. So now they're just sort of trying to make adjustments to the periodic table. Now, I really don't have a whole lot of problem with this. These are just bigger and bigger and bigger and bigger balls of nuclear cores of these particles. The bigger they get, the more attractive the dark matter is. The dark matter that's involved with the white matter here is so attractive that it wants additional electrons to come in. But once it hits a certain resonance value, with a certain quantity, and I can't tell you exactly why that happens, but it appears to be something to do with vibration, it locks in. And then it says, okay, we got just enough now. And more say, I want to get into that dark matter because the dark matter is pulling at me. And it says, no, you can't get there. So you end up getting out here. And you can stay there, but no closer. And I can show that, and I will right now. All right. I told you that the dark matter is extremely attractive. And it's so attractive, it's more attractive than the white matter is pushy. So once we establish these periods, these quantities, they become stable in the core. And then, but the black particle is so attractive that it wants to still drag in more particles. And here is exactly the nucleus of every single atom. Every single atom is constructed this way. There's dark matter, which is the positive, let's say. There's the white matter surrounds it, because the dark matter doesn't mind being on top of each other. They don't care about being right next to each other. The white matter hates each other. So they pull away at intervals and they create these elegant patterns around an extremely attractive center. So this is not just a neutral particle. This particle still wants more of these to come into this. But these say no, we have just the right amount. Even though you want more, we won't allow that. So this one still says, everybody come on around here, I'll take another one or two. And depends on how many there is around here, they will try to come in and they will set up a pattern surrounding this, but not touching. Because these say, I won't let you come and touch me. If we need an extra one, yeah, come on in, boom, right up, and you'll be right along in with these guys. But if we don't need you, you cannot come in. And here's what happens, exactly the case. All right? There's going to introduce another electron. Boom. It will not allow it to touch. That's what's called the quantum field effect. It says, no, you're not allowed in here. But the only way you can do that is to have a dipole. You can't have just one big positive and a negative out there and say, no, you can't come in here. So why? I'm a negative, you're a positive, I'm coming. And you wouldn't be able to do anything about it. Just boom, come, done. This has to be a dipole. There's no other possibility. And this will stay along with that particle because it's stuck in that, just like every other molecule there is, every other atom there is, has a certain number of particles surrounding it. And the bigger this core is, the more particles will surround it. And then eventually, when they heat up and they really get whacked, boom. You see it take off? That's heat, ablation. It's driving that ionized particle off of its attachment to its atomic core. That's what that is. Okay, so last word from Don, and then last word from me coming up. Here goes.
Okay, now to get into something you might not have known. Let's move into this new material. And I want to tell you something, and that is that these equations aren't completely true. That's right, you've been lied to. Wake up, sheeple. The man is lying to you.
And he is the man. Okay, so, and he admits that. He says, I am the man. So let's see what Roger has to say. Only one last thing I want to mention is that now it is understood. He said that nobody understands it, just go back and say the same things I'm saying and you're good. Well, no, now it is understood. This is the nucleus. This is quantum. I showed you what quantum is. I showed you what quantum does. We are all made of matter. Matter is made of molecules, which are big clumps of particles. Those big clumps of particles are made out of atoms. Atoms are all of these different stable zones of particles. So all they are is bigger and bigger chunks of particles, but they're zones of stability. And once you get down below these, you're down in this range. You're down into the protons and neutrons, and they seem to get stable around 1839, 1840. I don't disagree with that. But they are made out of all these little tiny particles, not one big, huge proton, as I have shown you. These will divide, these will come back together. Electrons and light is atomic vapor. And if you spray that vapor onto something, it's going to accumulate, just like they have these 3D printers, and they just grow. Same thing with this. These are electrons and they're dipoles, and they glue together until they turn into molecules. and atoms and us and the universe. Okay, like I said, I've gone to a lot of different classes, to a lot of different schools. The University of Geneva for particle physics, Yale, I've gone through their quantum stuff. It's just not right. I look to see what they have to say, but this guy, Professor Shankar, I think his name is, he's the most honest guy I've seen yet. Listen to what he has to say. This is Yale University.
So this is a very exciting day for me, because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively, and the good news is that nobody can follow it intuitively. Richard Feynman, one of the big figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys, because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So.
In quantum mechanics, absolutely, because there is nothing to teach. It's just you repeat what I tell you. It doesn't make any sense, but we all know that. Just repeat what I say, and you'll be good. And Don has read all these books, and he repeats what they say, and it's just, Don's not really working at this point. And I believe it's incumbent on any academic and teachers, absolutely, and certainly government people are trying to get free energy for us, to look into this. I presented evidence, not just equations and square this and square that over this and divide by whatever. The evidence is overwhelming at this point, so I suspect, hopefully I'll hear from Don. I consider Don a friend of mine. I don't think he necessarily considers me his friend. I don't hold any grudges. You know, we didn't hit it off all that well, but you know I was invading his territory. But as far as I'm concerned, they invaded my territory 50 years ago. I was in nuclear missiles in the Army, and believe me, I was, like I showed you. I think I showed you all my paperwork and stuff that I did. I didn't just breeze over the top of things, and you know, I actually got into the nuts and bolts and particles, and you saw the research we did. It's not something to dismiss out of hand. So I'm hoping we're going to get back together here, Don. Thank you, my friend.